All right, so look, here's the thing. Calculating confidence intervals isn't hard. You just need a little bit of practice and you need to follow the proper steps, the proper process. And that process comes from knowing the underlying idea. You got to know what we're doing here. That's how you remember what the process is. That's how you remember what the steps are. It's kind of what reminds you what the formulas are. And then that's how you can complete questions like this. So let me take you through the idea of what confidence intervals are doing, and then we can move forward from there. Okay, so we're going to start off with the idea, thinking about it like this. Now, we have a population. That population has a distribution. And the thing about that population is that it's going to have some number of interest to us. So maybe we're talking about the population of the United States, and maybe we're interested in knowing what the average height is. That's the mean, or what the mean weight is, or maybe some proportion of people who do a certain thing, like wear their seat belts in cars or want to vote for a certain proposition or something. So these numbers of interest are called parameters. Populations have parameters. Parameters such as the population mean or the population proportion. And we would like to know what the values of these parameters are. But in order to calculate those, we would have to ask everybody in the population so that we could get all of the numbers in order to do the entire calculation. And we can't realistically ask every last person. So even though that number does exist, we cannot ask everybody in order to figure out what this number actually is. That number is out there, but we just don't know what it is. So in that case, what do? We take a sample from that population, and then we take the numbers from that sample and we find a sample mean or a sample proportion. These numbers are called statistics, and we use these sample statistics to have an estimate of what the population parameters really are. That's why this class is called statistics. It's all about finding these numbers so that we can have an idea of what these numbers are. That's why they use different symbols. That's why you have the Greek letter mu and the letter P for population parameters, but down here we have English letters. We have X bar and P hat to signify that these are sample statistics. The other thing about sample statistics is that they're not all going to be the same. You could go out and get your own sample, crunch those numbers, and get your own statistic. Meanwhile, me or anybody else can go out and get our own sample. And that sample is going to come back with a certain mean or proportion. Everybody doing their individual sample will come out with their own different sample statistics. So the sample statistics, they're not going to exactly match the population parameter. But what we can do is we can give ourselves a bit of a give and take. And in order for us to get that give and take, that's why we calculate something called the error. So basically, we're doing something like this. Let me put this over. Let me try to line it up a little bit. There we go. This is what we're trying to do with the confidence interval. I'm going to calculate an error number from the data that I got, and then I'm going to add and subtract that error number to the sample mean or the sample proportion that I got. And by doing that, that is how I get my interval. So once I calculate that error number from the data that we got, I'm going to add it and subtract it from the sample mean or the sample proportion. And that is what's going to give me my interval. That's what's going to give me my two numbers on the outer sides. It's going to give me a lower bound, it's going to give me an upper bound, and that's going to be my interval. In fact, that's going to be my confidence interval. Then I can say with a certain percent of confidence that my interval contains the unknown, unseen population parameter. This is the ballpark I was talking about. That's the goal here, to be able to say that the reality number is somewhere here in this ballpark, hopefully. And by the way, I should note, the bigger the confidence interval is, the bigger the percentage, the wider of a spread that we get. So that's how come we're more confident that we captured the reality. It's because we've given ourselves a bigger ballpark. We've given ourselves a big error number. Now, if I was to use, say, for example, a smaller confidence interval, that leads to a smaller interval. The error is going to be smaller. So we have a little bit of extra chance that we're going to miss that parameter that we're looking for. That's like in this example that I drew out, we barely caught that parameter. And we'll see that in the math. We'll see that if the confidence interval is of lower percentage, it makes the interval a little bit smaller, which makes it a little bit harder to capture the reality. And so some of those samples are going to miss the reality. And so there you have it. That's the idea behind this whole thing. Let me go back to this one. The idea is we're going to make ourselves an interval. And now that you see that that interval is made up of the p hat or the x bar, it's made up of an error, and then you add or subtract those to each other to give you your outside intervals. Now that we know that, we can look at the formulas. These are the formulas if we're talking about proportions. There are different formulas for means, and there's even different formulas for the standard deviation, but for now we'll go over the example that comes with the proportion. So what we're going to do, step one, is we're going to find the point estimate. In this case, it's finding the sample proportion. We also refer to that as p hat. And in order to find that number, you're going to divide your x and your n, where x is the number of successes that you have, and n is the number of trials. In other words, it's the sample size. You're going to have to read the question very carefully in order to find out what those numbers are. Then your second step is that you're going to find the margin of error. This is the formula for the margin of error. It has a z-score, that's your critical value. That's going to be dependent on what type of percentage confidence interval you're using. And we'll get to that in a bit. That's like a little bit of a side quest. We'll cover that when it comes time. Then you're going to square root the p hat times the q hat divided by the n. P hat is the number that we'll already have. We'll also already have the n. Then it's just a matter of finding q hat. That's not too bad because q hat is going to be 1 take away p hat, and we have what p hat is. So it's very easy to find q hat. Then finally, we get to do the actual confidence interval, where we're going to say that hopefully the reality is between the lower bound and the upper bound, which is made up of the p hat minus or plus the margin of error. And those are going to be numbers that you've already found. Using those numbers, you plug them in here, you crunch out what your confidence interval is. And by the way, there's different ways that you can write out this confidence interval. This is the one that's pretty typical, at least in this class. But you can also write it in interval notation, where you just take those numbers and put them in the parentheses and put a comma between them. You can do it that way, Or you can even write it in this format where you just say what the p-hat is, and then you write plus or minus, and then you write the error number. Sometimes they're going to want you to say it in that way, but most of the time it's going to be like this. But just know these other ones can come out. So in any case, what's going to happen is that your final answer is going to be this confidence interval. You're going to say, the language you're going to use is you're going to say that we are a given percentage confident that this calculated interval captures the true population proportion. You have to say it that way. You cannot say it the other way, because then technically it wouldn't be accurate. It's, if you're doing a 99% confidence interval, then you are 99% confident that this interval captures the reality. That's the way you want to remember to say it. All right, now with that underlying idea in mind, this whole process that we've been talking about, let's try to look at a question. Okay, so I made up a quick question here. I'm talking about flipping coins. That's my drawing of a coin. And in this question, we're saying that we're going to ask 100 people to flip the coin once, and let's see what they get. 55 of the people got heads, which means 45 of them got tails. And the question is, what is the 95% confidence interval? And as a bonus, we can talk about is if it's possible that this coin is a fair coin. In other words, that it's a 50-50 shot to get a heads or a tails. Now that we know what the question is and we have the idea of how to go about solving these questions, we go about that step-by-step process. What is step one? Find what the point estimate is. Find the sample proportion, otherwise known as the p-hat. So for step one, we want to find the point estimate. The question tells us that our number of successes, if we're going to let success be getting a heads, then our number of successes is 55. That's our x. And we tried this with 100 people, so our sample size is 100. So based on the formula, p-hat is going to equal to x over n. So that means that that equals 55 divided by 100. And so that, when you put it in the calculator, it's going to equal 0.55. So your p-hat is 0.55, and that's your first step. You found the sample proportion. Step two is that you're going to try to find the margin of error. Now, in order to find that, you're going to need to use this formula here. We found what p-hat is. Then we can quickly figure out what q-hat is. We know what n is, right? And then we can figure out what this is afterwards. So p-hat is 0.55. Q-hat is equal to 1 takeaway p-hat. So just plug it in. 1 takeaway 0.55. Do that math, and you see that q-hat is equal to 0.45. Good. Now we have these two numbers. Of course, we saw that n is equal to 100. All those numbers are going to get plugged into the formula. You can see it right here. P-hat is 0.55, Q-hat is 0.45, n is 100. Now, what about this number? What about this critical value right here? In order to get that number, we're going to have to kind of do a little bit of a side quest here, so let's get on that. All right, in order to find that critical value, that z alpha over 2, that's going to be dependent on the fact that the question asked us for a 95% confidence interval. So what they're saying is that the confidence interval is going to be a 0.95. We write that in decimal form. And the alpha part is going to be the area outside that. So what you do is the formula you use is 1 take away that confidence interval. That confidence interval is 0.95, and if you go in the calculator, 1 take away 0.95, that's going to equal 0.5. That is your alpha. But we need to chop that alpha into two pieces. So if you put the alpha, the 0.05, and divide it by 2, the calculator will tell you that that answer is 0.025. The reason we do that is because now this is using the picture of the standard normal. That's what the z-distribution is. It's a standard normal. The confidence interval is telling you that it wants 0.95 in the middle. The areas outside of that is your alpha. And because of symmetry, you have to chop that up into two equal pieces. That's what you're doing here. So, based on this math, you're going to have 0.95 in the middle, you're going to have 0.025 on the outsides, which is appropriate because the entire area under this curve has to equal 1. The critical value is this point on the number line that gives us this chop up. That's what we're looking to get. That's the number. So now that we see that we got 95 here and we got 0.25 here, we can go into Excel. Excel's really helpful. And we're going to use the formula. We put in equals norm.inverse. Then the Excel is going to ask us for three numbers. It's going to want what's the probability to the left, what's the mean for the standard normal, 0, and what's the standard deviation for the standard normal, it's 1. You put that in Excel, and Excel is going to tell you that the answer is 1.96. I rounded it. That number is this value right here. This is the 1.96. That is the critical value. And by the way, just to give you a little bit of an extra shortcut to get this probability to the left, if you don't want to calculate all this, use this little shortcut. To get the probability to the left, just use the formula 1 plus the confidence interval divided by 2. In this case, the confidence interval was 0.95. You add that to 1, then you divide it by 2. It's going to give you that 0.975 that we had to plug in right here. So that's a nice little hack. All right, now that we've completed that little side quest, we have figured out what the critical value is. That is going to get plugged in to the equation for the error along with all these other numbers. You can do these on a calculator really quick, and that will give you a final answer of 0.0975. I just want to say something that I think is kind of important. In this video, I'm just going over the idea of how this works. I'm not doing the calculation. I'll do the calculation in another video, but I really want you to take some time to understand the idea. The numbers are going to be what they calculate out to be, and that's fine. But the thing about it is you have to understand the idea to even put in the numbers to set up your equation in the first place. A lot of students just want to zoom really quick to what do I put in the calculator? What do I put in the calculator? How do I do the calculator? And then what happens is they get to the test and they don't even know the idea, so they don't know what numbers go where. And then, in that case, the calculator is kind of useless to you because you don't even know what numbers to put in the calculator. So in this video, I just wanted to focus on the idea, and then I'll do another video where we go over how to do the calculations, both on the calculator and in Excel. All right, so now we've finished step 1, we finished step 2, we have the p-hat, we have the error. Now it's finally time to do step 3 and get the confidence interval. I've got that right here. There's that formula again. It's the lower bound and the upper bound. And in order to crunch that, we need to know what the p-hat is from step 1. We know what the error is from step 2. Now we can plug those numbers in, calculate that, And these are the final numbers. You do the subtraction here, you get this. You do the addition here, you get this. And this is your final answer, the confidence interval. We are 95% confident that the reality, that the true population proportion is in between these numbers. So picture-wise, it kind of looks like this. Here is your interval. Here is the p-hat we got. Here is the lower bound and the upper bound. That came from knowing what the error was and adding it or subtracting it, which lets us know that, once again, the proper language, we are 95% confident that this interval contains the real true population proportion. By the way, if you wanted to write that in the other ways, the interval notation would look like this. That's just these two numbers inside the parentheses with a comma. Or if you wanted to write it in this form with the p-hat plus or minus error, it would look like that. And finally, to answer that bonus question, is it possible that this is a fair coin? Well, taking a look at the interval we calculated, let me put this right here. As we can see, this interval does contain what a fair coin would be. A fair coin would be 50-50 heads, right? And that is a possible number in this interval. Therefore, absolutely, it is possible that this coin that we did is a fair coin, even though we didn't get exactly 50 heads. We got 55 heads. But it is still possible, given this interval, that the proportion of the coin is 50-50. And there you have it. That's how you answer a question like this. You want to remember these equations. You want to remember those steps. And those steps come from the idea. Try your best to remember the idea behind it, and then have a little paper where you write down what the formulas are, and that's what's going to lead you to some success in solving these questions.